All right, welcome everybody. Zoom in and enhance. Yes. So we're going to continue our discussion of classes today, and I'm going to try to put the first class's recording up this time. I normally put up the second class because it usually goes a little bit smoother after I've kind of worked out what I want to say, but at the same time, a lot of the spontaneous humor gets lost, so the second class is a lot smoother and perhaps a little less humor. So for today, we'll do you guys. All right. So if you have any jokes to make, now's your opportunity to do it. I'll make sure this one goes up on YouTube, unless I screw up really badly, in which case we'll just pretend I never said this, and we'll do the 2 o'clock class instead on YouTube. Okay. Extra credit. The Laden talk didn't work when I tried watching it live. However, a recording has been posted, and so if you go into the extra credit section, the extra credit talk section on Canvas, you'll see that there's a recording. You can click on that, watch it, write a 1 to 2 page essay about what he talked about, what you learned, pick up a couple points on the daily quizzes. Okay. And then I am giving a talk, or my friends are giving a talk on Friday, more extra credit. Okay. I've never heard students complain about there being too much extra credit in the class, but who knows, maybe this will be the first semester. We're doing a lot of extra credit. That will be on the Society SCA, the Society for Creative Anachronism of Creative Anachronism, whatever. Basically, it's medieval reenactment kind of stuff. So it's kind of a nerdy hobby I have, and so you'll learn about that on Friday from 4 to 5 p.m. here on Discord. Okay. Any questions about it? Your side books is due on Friday. About pointers. So we're going to go over today more stuff that will help you do the side books. We also need to talk about mountain bridges too, don't we? So a lot of people were contacting me over the last 24 hours, and it's like, what I would like to reemphasize the point: you need to start your homeworks early so that when you get stuck and you realize you don't know something, you have time to get unstuck. It's the single most important thing I can try to emphasize to you guys in computer science is that everybody gets stuck. Don't beat yourself up. Don't be like, oh, I'm stupid or whatever. Everybody gets stuck when doing computer science at some point or another. And when you get stuck, you can either beat your head against it for 8 hours, or you can ask somebody for help and try and figure out why you're stuck. And then they'll help you get unstuck. And so we've got Corrente and Mincarelli and myself and the tutorial center and the help center. There's a lot of opportunities to get unstuck. But if you're doing it within the last 24 hours before a homework assignment's due, it's probably too late. The last 24 hours are usually, when I did computer science, that was my buffer zone. So I try to have everything in 24 hours before, and then if I effed up really badly, then I would have an extra day to work on it. And it would happen, where like I'm doing it and the code's just not working right and I can't figure out why. So I start scouting all the things, and it takes a while to figure out where your code is going wrong and why it's going wrong. And so my personal goal is always get things done a day beforehand. And maybe I should have been like 3 days beforehand, but it worked out pretty well for me in most cases. Once I got burned, I finished it at 11:57 for a midnight collection, and they had collected it already. They collected it at 11:55. And that annoyed me because I got a 0 on the homework assignment and it was missing a semicolon, and I had it done prior to the deadline. They just collected it early. It's 2 minutes. So that lowered my grade in the class by like half a letter grade. I was kind of upset about it, because if you tell me you're collecting at midnight, collect it at midnight. Don't collect it 5 minutes before midnight. But that's again a reason why you shouldn't be like bumping up against deadlines like that. Okay. Is the books due on Sunday? Okay. Yeah, I pushed it back because there was, that's right, it was originally due on Friday, and I pushed it back to Sunday because some students are having trouble submitting it on Canvas. The integration between Canvas and Zybooks is screwed up, maybe still screwed up, I don't know. Tell me if it's not working for you, and I'll try and decipher it. Okay, so yeah. So let's first of all talk about Oh wow, yeah, that's pretty impressive. Main2.cc. Let me just throw out something real fast. And array width times. Okay, so we're talking about the homework now, by the way. So we're going to get the width and the height somehow. In this case, from the homework, the width and the height come from a file. But reading from a file and reading from the keyboard are essentially the same thing. You just have a variable that you read from. And so on this assignment, it became clear that a lot of students didn't know how to read from a file. So your next homework assignment is going to be reading from a file as well. And yeah, and then we'll see how that goes. We'll see how that goes. Depending on, I always watch to see how the homework assignments go to determine, all right, do I need to like hit this topic again or move on? Okay. So this is what's happening in the homework. We got here a width and a height from the file. In this case, I'm reading from the keyboard. Doesn't matter. And what this is going to do is this is going to allocate a chunk of memory. So it's going to allocate, like if I type in 10 and 10, width times height, hence. Okay. So if I type in 10 for the width and 10 for the height, it's going to allocate memory off the heap. It's going to heap allocate, not off the stack. Remember, we had that whole lecture on heap and stack, so if you don't know what I'm talking about with the heap, please watch that. It's pretty important. So it's going to allocate off the heap 100 integers, which is 400 bytes of memory. And this is going to return a memory address. And so if I come up here and scout R, and I could even do pretty print it a little bit. Probably, yeah, it's not going to like to print that. Okay, so here we go. Wrong one. G++ main2.cc. Please enter a width of 10, height of 10. Let's line these things up. I'm going to just make them an integer so you can see kind of what's going on here. By 10. Okay, so at memory address that is where it allocates 400 bytes of memory and is going to give you a pointer to the beginning of it. Okay. Then 100 integers later, actually it's 100. I'm adding 100, aren't I? I need to do this with size of int times width times height. 10 by 10. Okay. So this memory address, it found room for the array, and it allocates 400 bytes of memory, and then it returns a pointer to the beginning of that chunk of memory. You can see right here. That's the spot in RAM where that 100 integer array lives. The end of the array is 400 bytes later, because every int is 4 bytes. So 400 bytes later is the end of the array, and that's technically one past the last valid byte in the array. Okay? So new is going to permanently allocate that memory until we delete it. So if we did this, if we move this up into a function, so if we put this up into a function, we could allocate the RAM up there, and that RAM is still allocated when we return back into main. Okay, if this was a stack allocated variable like this, you can't return it. Or you can, but it'd be really bad. This is allocated on the stack. Okay. So if we were to return array 2, this would be really, really bad. Why? Address of stack memory. Why is it bad to do this? Garbage collector? There's no garbage collector in C++. There's things called smart pointers that kind of work with it. Like that. So let's go over stack and heap again. So when you call a function, in this case we're calling alloc array, your memory map looks something like this. The minefield of doom down here. Code segment, BSS, data segment, which is the heap, stack, goes down. Okay. The stack pointer, it's pointing to a certain memory address. When you call alloc array, the stack pointer moves down, and it moves down far enough to hold all of the variables that are stack allocated. In this case, we've got an array of 100 integers, and we've got a pointer, and we got width, and we got height. Okay. So this is going to allocate memory to hold width and height and R and R2. So when we call alloc array, we call alloc array the stack pointer, which you don't ever see or need to worry about. It moves down to here. And it's going to move down how many bytes? It's going to move down how many bytes? How many variables do we have here? We've got 4 variables, right? This variable is 4 bytes, this variable is 4 bytes, this variable is 400 bytes, and this variable is 8 bytes. So it's going to move down 116 bytes. Plus there's some bookkeeping, but let's just say 116 bytes down. Okay, and then as long as this function alloc array is running, all of these variables have a spot in RAM. Like width has a spot in RAM, and you can read and write to it. We can set it equal to 10. You can set height equal to 10, and R could be set to some memory address, and R2 could be set to some memory address. When the function returns, the stack pointer goes back up where it was before. Like this. And all of these variables cease to be. We can return a variable back to main, and that variable that we're returning is a memory address. And so up here we're going to have some variable called R, unfortunately named the same as this R, and that R is going to be pointing to this spot in RAM. What's the problem with that? Do you have a pointer to allocated memory or unallocated memory? When we're doing this, we're returning the memory address of these 100 integers here, but they've been deleted. They don't exist anymore. Those spots in RAM could be used for your credit card number or for your social security number. Or it could hold the old data there. You don't know. Okay? So if we were to read and write to this, like, let's do this. This is terrible, but let's do it. Is equal to 1, 2, 3, 4, 5, 6, 7, 8, 8, 9, 10, and all the rest will be zeros. Let's just for int I equals 0, I is less than 100, I plus plus, see out our square bracket I. Let's just print out all those values in R. And it should return, this for loop here should print out 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and a bunch of zeros after it, but it might not. Who knows? Because that array that we're printing out the values for has been deleted. And there's no guarantees that any of those values are going to be correct. So we'll type in 10 by 10, and we segfault. All right, because we're accessing memory beyond the stack pointer. Okay. When are they deleted? They're deleted. All stack allocated variables are deleted when you return. When you return from a function, all those variables get deleted automatically. That's why they used to be called auto variables. Auto used to mean a stack allocated variable. So they get newed, they get created when you call the function. When you call the function, the stack pointer moves down, and all of these people get created. And when you return, the stack pointer moves back up, and they get deleted. And you don't have to, for normal variables, you don't have to worry about newing them and deleting them. Okay. I'm running that code, but you're getting a memory leak. Yeah, because we're not deleting. Because why do we have a memory leak? Because of this line right here. We're calling new, but we're not deleting it. We violated the Sith rule, right? So if we return R, this is okay. Why? Why is this okay, but R2 is not okay? You can return a pointer. I'm returning a pointer. But I'm returning a pointer to something on the heap, because the heap is permanently allocated. This array here, R2, which is, we will call it the mayfly array, that array vanishes when we return. So we cannot return a pointer to it because it's gone. It's been deleted. Okay, but we can return a array enjoyer because this memory address here, return from new, is on the heap. So where is R? R is down here. Okay, so when we're newing something off the heap, R is going to be 400 bytes of memory down here somewhere in the data segment. And so when we return it, rather than pointing at unallocated memory off the stack, it is pointing at allocated memory on the heap. And that's fine. That data will stick around until the end of your program. Only variables created in a function get deleted right. All variables that are not newed all variables get destroyed when they hit a close brace, essentially. Okay. The end of their scope, let's put it that way. So when you hit the end of the scope in which they're created, width goes away, height goes away, mayfly goes away. The pointer itself is about to go away, but the memory address, all this chunk of memory here, is safe. It's not destroyed because it's heap allocated down here. This is the heap down here. It's heap allocated, it's not stack allocated. The stack's up here, the heap's down here. Two different sections of memory with different uses. Okay. And so we return this value to preserve it, to keep it alive. And then when we do this, you can see it doesn't segfault. Okay. How big is the heap? I think we ran that in the last lecture. I think we determined it was like, it got up to like 2 terabytes or something before it crashed. The heap's technically unlimited in size. Now you can't actually use 2 terabytes of RAM, but you can allocate it. You can pretend that you have it. If you try using it, it's going to probably die at some point. It's limited by your RAM plus your hard drive size, more or less. Why is R in the heap? The pointer itself, this variable R, is on the stack, right? If we don't return R, then that variable goes away. It's a variable that holds a memory address. It's a variable that holds a memory address of 400 bytes of memory. So the variable goes away, but when we're returning it like this, we're passing out the memory address of the 400 bytes of memory, and that array, that 400 bytes of RAM, doesn't. There's 2 things, right? You've got a variable here on the stack, and what is the variable in the stack pointing to? It's pointing to a chunk of memory on the heap. Okay. So there's a very tiny little thing on the stack that holds the memory address of a big chunk of memory on the heap. Can you return an array with a delete? No. What does that message mean? That means you violated the Sith rule. So if you do a new, like we're doing here, if you do a new and you don't do a delete, then you done goofed. You have violated the Sith rule. For every master, there must be an apprentice. Excuse me. For every new, there must be a delete. Okay? So if I compile this with the address sanitizer tone, sanitize equals address. So if I run my code with the address sanitizer turned on, main2.cc, sorry, is in width 10 by 10, then it will notify me that I have a memory leak. That means that I newed memory and I didn't delete it. It's called a leak. A memory leak is not as bad as a double delete, a double free, which crashes your code. But it's bad because you're wasting memory. So it tells you where you did it too. So line 10, then main.cc line 10. You guys have all seen this before, right? Line 10. Oh, wrong one. Main2.cc line 10. That's where you newed the memory. You didn't delete it. Address sanitizer is a cool thing. It's turned on by default when you use compile. That's why you were seeing the memory leak and I wasn't, because you're compiling it with compile or something. So if you put new before each variable, it will not get deleted. Yeah, but that's not a good thing. Usually you want your width to be deleted, right? You want variables to go away when they go out of scope by default. It's only for things like this where you're like loading map data or something like that. You want it to stick around for a while. So to solve this, we're going to do a delete on our square bracket 0 equals 42. Okay, the rest of these are uninitialized. Okay. So it would be really cool if there was some way of like, oh, I don't know, automating that process so that you don't need to worry about a new and a delete, right? And remembering to delete your thing. And especially when your code gets really complicated, you know, and you've got a pointer like this, you're not really sure, like, am I supposed to delete it? Is it an array or is it a pointer to a regular variable? You don't know. If all you had to go on was this line right here, I don't know actually if I'm supposed to delete it or not. I don't know. I have not enough knowledge to know if I'm the owner of it and I'm supposed to destroy it. So that brings us to today's topic, which is let's do constructors and destructors. Okay, so let's come down here. Let's just purge this whole thing. And let's make a class called, I don't know, like vector or something. Actually, let's start off with struct Bob. Let's just show a simple example, int x, y, z. And I guess this is a vector 3 or something. Okay, so a vector 3 would be used for like physics simulations and video games and things like that. So points in space have like an x, a y, and a z, right? That makes sense? So I can make vec3 point 1, and I can set point 1's x to be 10, and point 1's y to be 20, and point 1's z to be 30. Do you get what this means? I'm creating a, like, imagine you have a 3D coordinate system. Point 1 is at location 10, 20, 30, and like a 3D. You guys get this? Like, not even the computer science. You just, like, do you understand, like, maybe I'm trying to do like a physics simulation, like maybe I want to have a racquetball that's going to bounce around inside of a I don't know, a racquetball court or something like that. So it's going to have, like, I don't know, like a position, like instead of calling it point 1, let's call it like position or something like that. And then maybe we can have another one for velocity, right? So we can have we're going to be at some point in space and moving in a certain direction. Okay. And so its position will be 10, 20, 30, and its velocity will be 1 to the right in the x direction. Conceptually, do you guys understand what I'm doing here? Like, I've got some sort of racquetball court, maybe I'm simulating a pool table or something, and I just have these two variables. One is like the position of my ball, and the other is the velocity. And so it's traveling at 1 centimeter per second to the right in the x direction. You guys comprehend? So, let's write this. I don't know. Let's just do this code real fast. We got 45 minutes. So, all true. What do you want to do? Let's have a racquetball bounce around or something. What do you think? You guys want to see a racquetball bounce around or something? H. Could do like non-blocking I/O. I don't know what I'm doing here. What was the name of the assignment that you RPG? Let's take a look. I'm just going to copy the boilerplate code out of this. Maybe I can like control it with like my mouse or something. Would that be fun? Like I could like use the arrow keys to like have it not just move its position, but actually move its velocity. Maybe we'll just do a vector 2 instead. Let's not worry about the z direction right now. Just have it bounce around on the screen. Okay. Okay. So indubitably, all right. You know, I'm just going to copy this whole thing out. It's going to be, okay, copy sample non-block IO up into main2.cc. It's going to be faster for me to do it this way rather than pulling out pieces. The world map is just going to be ten insert space dot 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 10 insert star dot. There we go. Make the world a little bit bigger. Okay. All right. Print the world. Okay. So the row and the column. Okay. So let's do a class now. Class vector2. It's got an int. We'll just do an int row and an int column. Okay. So we're going to have a vector2 called position, and it's going to be initialized to rows divided by 2, columns divided by 2, and we're going to start off with a velocity of 0. So the last row and last column, just call this like last position. Yeah. Okay. So we're going to set raw mode on, and then we're going to quick read, and then rather than row, this will be position dot row. Position dot row, position dot column, position dot column. So WASD is going to move the position around, and then I think what I want to do is have the up arrow and down arrow and stuff like that affect the velocity. Okay. So I'm going to have WASD move the position, and then arrow keys add or subtract velocity. Sorry, I'm just going to refactor this real fast. It's faster than writing it from scratch. And for those you're like, oh, it's so fast. No, there's a reason why I'm copying and pasting this code. Right? D7W, nope, too much. D5W, there we go. DTO, there we go. YYP, DT, close parentheses, DTR, okay. WASD. So I'm refactoring this to use classes, okay? So I've got here a vector, and so rather than having just a row and a column and a velocity x and a velocity y, I'm going to start grouping these things together into ways that kind of make sense. And what's nice about that is then I could like maybe make a vector and have different balls bouncing around all at the same time, right? So CW velocity dot B to go back dot. Okay. And so that is that. Okay. So now we need to run our physics engine. Run physics engine. So I'm doing a lot of refactoring here. Sorry. All right. So if they didn't type anything, then actually we don't want to use sleep, do we? Because we want our physics engine to run. So we'll just do that. So we're always gonna sleep. Okay, so for our physics engine, how does it work? So I think we're good on this front. I think we're gonna compile just fine. Let me just blue. Okay, then also output the velocity, and then we should be good to go. Velocity in the x direction is going to be velocity dot column, and velocity in the y direction is going to be velocity dot row. Maybe I should do this backwards. How does velocity work? What does it do? We got half an hour left. We can do this. I'm checking position.call equals position.row. I don't think so. I don't think I should be doing that. Where am I doing that? What I'm doing is saying if I have moved since the last frame, then I'm going to redraw the screen. So if we're stationary, it's not going to redraw the screen. Yes, thank you. Perfect. Okay. Okay. So what do we do? How do we do physics? Let's first test this. Let's just make sure that everything works with this. Well, it's not printing anything. World map.size, world map.size. True, show cursor. So we're calling print world, passing in the row and the column. Print world clears the screen, moves the cursor to the top. Let me just see out hello world just to see if that's coming on. Nope, that's not coming on. Color maybe? All right, let's do some debugging. Oh, because it's not moving, that's why. So we're never calling print world. Okay, so. There we go. So you use WASD, and then the arrow keys are not working. So it's not refreshing. Yeah, it doesn't refresh until something happens. So I'm actually gonna just pull this out here. So I can adjust the velocity. It's currently not doing anything. I can adjust the position. Gonna need to add some spaces in here. Okay. Yeah, exactly right, Mr. Bell. Exactly right. So, physics engine. How does it work? How does physics adjust position? Where is the position function? Position is the class that I made. So I made a vector 2 that holds just an x and a y thing. And so I've got one for where I am, what row and column I'm on. I've got one for velocity in the row's direction, the column's direction. And I've got one for last position, which you might not need. All right. Okay. So what we do is we say position.row plus equals velocity.row, and positions column is plus equal to velocities column. That's it. That's physics. That's our physics engine. If I hit up, flies off the top of the world. If I hit down, so it's flying right past. We got 100 frames a second, so it's a little bit quick, or 60 frames a second. Let's turn that down to 10 frames a second. Okay. So what do we need to do next? Clearly, have it bounce, right? So how should we do that? What happens when a ball hits a wall? Through a racquetball. What happens when it hits a wall? It goes in the other direction. Yeah. So if position dot row is less than 0, so if we move off the top of the world, or position dot row is greater than or equal to whatever vertical size is. What is that? World map dot size. It's the number of rows. So if we go out of bounds to the north or south, then we flip our velocity around. Velocity dot row times equals -1. So we go in the opposite direction. And we'll do the same for the column. So if you go off the left, then you switch the velocity around to go to the right. If you go off the right, you switch your velocity around to go off the left. This will work fine as long as you don't start outside of the world. If you start outside of the world, then it won't work. But we're starting within the world, so it's all right. You gonna see something cool, Mr. Bell? Always. So you know how we're getting these warnings? Comparison of signed and unsigned. You know, it's kind of annoying. Right? Not added yet. Oh well. So there's a member function called size, which is a signed size, which is a new thing in C++ that will have you not need to do that. Okay, so there we go. So it is bouncing right now. Copy paste error. Oop, went out of bounds. Ah. So that's the number of rows. That's the number of columns. Crash. So when row becomes -1, it goes out of bounds. Ah, because of this. Yes, okay. Let's just assume it's rectangular in size. Make life simple on us. Boink, 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 boink. It's like the DVD logo. You sit there and watch it all day hoping that it hits the corner. I think it did. I think it actually hit the corner. Yeah. Okay, so that didn't take too long. It was 20 minutes. It's a bit weird. The particle goes in the wall, then bounces. Yeah. We can fix that. Should we fix it? Yeah, why not? Okay. Fine, we'll fix it. We'll fix it. We'll invert the velocity, and we will set position.row equal to clamp. We're going to clamp position.row to be between 1 and, because the 0 row is the wall. So technically it should bounce at 0, right? And it should bounce 1 off the thing here. So we're going to clamp it to 1 and world map.size -1. And so you don't exist? I thought you existed. Right, because that's a... There we go. Okay. So clamp is a function that will ensure that the value is between 2 values. So if it's 5, it'll just be 5, but if it's less than 1, it'll be 1, and if it's greater than the max row, it'll be the max row. So that's what clamp does. So clamp, if you clamp a value between 1 and 10, if it's below 1, it'll be 1. If it's above 10, it'll be 10. Otherwise, it'll be whatever value it is. So it's a really nice way of enforcing that a value is in a certain range. Added in C++ 20, I believe. All right, so now we'll do the same for the column, position.column. It's equal to clamp between, clamp between position.column. We're going to clamp it between 1 and world and that, basically. Not happy with me? Okay. So Mr. Bell didn't like my physics. It's fair. So, boop, 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 boop. Oh, it's I need to pull it off 1. you can still use WASD to move them around too, but the velocity is staying. What do you think? Kind of cool? We could check if it hit a star, but it could teleport through it, right? Because we could have a velocity that's much higher, right? And a velocity of 5, right? So the clamp is going to put it right at the last open spot, which is not exactly physically accurate, because what you should be doing is computing the amount of overshoot. So if the ball moved 5 towards the wall, but it got 2 and then flipped, it should be back 3. If you want to be physically accurate, but that's pretty cool, I think. Add more particles, up the FPS. Yeah, those would all be natural next steps. But what I want to show you is we don't really need to new anything on this, do we? What would happen if we did this? So we have a bowl of ramen bouncing around now. It's Unicode, so it screws up the character spacing and everything, but okay, so make it increase velocity every time it hits the wall. Yeah. Okay, so what's the point for today? There's a couple things you can do. So let's say that you wanted to allocate memory using new. You can make it so that it allocates memory so it allocates memory automatically, and it deallocates memory automatically, rather than you having to do it manually. With new and delete, you can have it do it automatically. I'm not sure why Vec2 would have a new memory. Maybe it's the history, right? Maybe we can have an int pointer here, which is the history of moves that it's made. Okay, and it will hold the last, I don't know, 10 spots that it's been to, or something. So we're going to learn 2 new things today. First thing we're going to learn is something called a constructor, and the second thing we're going to learn is something called a destructor. So a constructor, learning point 1, a constructor is a function that runs every time a vec2 is made. Or every time, yeah, we're in vec2. So every time a vec2 is made, this function is going to get run automatically. So if I make a constructor, the syntax for a constructor is this. The syntax is this: make a function inside of it with no return value, and the name is the class name. So it looks like this. Vec2, like that. And so every time a vec2 is made, we will see out I am made. Doesn't do anything. This isn't normally what you do with a constructor, but if we do that, we can't use universal unit. Yeah, okay, fine. We'll show you the proper way of doing it. So the way a constructor works is you normally have it initialize all of your variables, and you can have this thing here, which if you just make a vec2 like this. Like if you just say like vec2 hi, it'll call this one. Or you can make a constructor like this that takes in some parameters, like this. So So here, when we're making a vector 2, it's going to pass in rows, and it's going to pass in a position. It's going to pass in the row that we're at, which is going to be max rows divided by 2, and the columns we're at, which is columns divided by 2. So, so what do? In a constructor, we normally initialize our variables. By default, none of these bad boys are going to be initialized. So a constructor is usually used to initialize the variables. So if you don't pass in any, like if I just make a vector 2 like this, and I don't give it a row or a column, what row or column should it be on? Have it make it draw a trail? Yeah, that's a good idea. I might, actually. So if we're gonna, if we just say make a vector 2, what should its row and column be? What do you think? Yeah, default. Yeah, it's called a default constructor. Like, you guys know what happens when you do string s, right? You know how you don't have to initialize it? That's because it has a default constructor, and it will initialize itself to an empty string. So if we make a vector 2 like this, what should its row be? What should its column be? What do you think? Leave it uninitialized? I don't know. That doesn't seem like a good idea. I don't like uninitialized variables. 0? Sure, why not? Row equals 0, column equals 0. Maybe a problem with that in that it's technically in the wall, but you know, whatever. Okay. And then what should we initialize history to? History is supposed to hold the last like 10 spots or something. Or something like that. What do you think? Or the last 10, I need 2 of them, huh? Row history and column history. So we do something like this. We would say row history is equal to new int size 10. It's a magic number. Magic numbers we don't like. History size 10. So we don't like magic numbers. Let's get rid of that. History size here, like that. And column history, new history size, like that. Okay, so if we make a variable like this called high, then it will set high's row to be 0. It'll set high's column to be 0. And it is going to allocate memory to hold the last 10 rows that we were on, the last 10 columns we were on. Static, don't worry about it. It means it's associated with a class, not with an object. So it's not so it's not like you can say you know, position dot history size. It's actually part of the class, not part of an object. It's getting a little bit sidetracked here. So if we pass in nothing like this, it's going to allocate memory. Are we deallocating memory? No. Right? So we need one more thing, which is the destructor, which we'll get to in a second. Now, what if we make a variable like this? What if we make a variable like this? Vector 2 by row 5, column 10. If we make a variable like this, then it's going to pass in 5 for new row, and it's going to pass in 10 for new column. So what do I need to put inside of here? I need to write down row is equal to what? My row should be what? What should I write there? New row. Oh. Yeah. Column should be equal to new column. And then we're still going to just allocate a chunk of memory to hold our last 10 moves. You guys understand? So if you make so this allows us to make a vector 2, which holds an x and a y location, basically. We can either make it like this, where it has, we're passing nothing to it. And if we pass nothing to it, then its row and column are set to 0, which again is not great. because it'll be within the wall, but you know, whatever. Or we can initialize it like this. Or we can initialize it like this also. So this will set by.row equal to 5, by.column equal to 10, dsf row equal to 5, dsf.column equal to 10. Exactly the same. Exactly the same. So again, we're continuing our discussion of classes, right? And so class is a way of organizing your data. So do you understand why it makes sense for like a row and a column to go together, right? If you've got a ball bouncing around, it'd be really weird to have to track all the rows separately and all the columns separately. And in fact, this is a little bit weird. In fact, I would probably want to actually make a array of vec2s, really. I don't know if you guys are ready for that level of recursive. A class that contains a pointer to itself, like, what? You know, so I'm just going to do it the bad way for now. Okay? So what rule am I violating? I'm allocating memory. What do I need to do? Gotta delete that heap. That's right. So, when a variable leaves the stack, it calls the destructor on that variable, if it exists. Learning point number 2 for today. A destructor is used to clean up anything allocated in the constructor. You don't always need a destructor. You only need a destructor if you're doing something like this, where you've got a new. Okay? So there's a philosophy in C++, philosophy, called RAII, which means if you allocate something in a constructor, delete it in the destructor. You might ask, what does RAII stand for? It stands for resource acquisition as initialization. It means absolutely nothing. People just refer to it as RAI. But it basically means any of your news should be in a constructor, and any of your deletes should be in a destructor. And if you do that, then when the variable is made, it allocates memory. When the variable goes away, it deletes the memory. And it looks like this. Syntax for a destructor is a tilde followed by the name of the class. No return value. So it looks like this. So what do we need to do here in the destructor? What function does the row and column history have? Currently we're not using it for anything. But I was thinking it would be kind of cool would be to track the last 10 locations we went to. So every time we move, we write down our last spot. And so you could like maybe leave a track behind or something like that, you know? Like snake. Right? And it'd be kind of cool if it could grow over time like snake. You know, if you ever played the snake game where the trail it leaves behind gets bigger and bigger. Yeah. I'm not implementing it yet because we're basically out of time. So let me just show you what we need to do here. We need to delete the row history, and we need to delete the column history. And we're good. We're not going to leak memory. If I turn these lines off and compile it, G++, last one with the sanitizer on it, come on. I'm getting carpal tunnel. No. Okay. History. Pipe through. Grep. Sanitize. There we go. Run command 2568. There we go. I could have typed it faster. But if I run this, there we go. We got the ramen bowl bouncing around. I could probably write code to fix the thing moving like that, but I don't care at this point. When we quit, memory leak. Right? Because when we made position, it allocated memory. When it went away, it didn't deallocate the memory. Memory leak. Okay. So we're allocating memory on line 64 and on line 63. Line 63, line 64. We got news, we don't have corresponding deletes. So if we put the destructor in effect, then when any vector 2 goes out of scope, it calls the destructor and it cleans up the thing for us. Isn't that nice? Rather than you having to remember when you need something and when you don't need it anymore and deleting it, it just, when a vector 2 comes into existence, it allocates the memory for itself. When the vector 2 goes out of existence, it frees up the memory that it used. How could you make history a vec2 without history having a history forever? I would do this. If I was actually writing this, I'd say vec2 pointer history, like that. And so it would be I'd do that instead. So yeah, I don't necessarily want to explode your brains over this right now, but yeah. Then you would have a record of rows and columns, and each one of those would have an infinite. It would become recursive very quickly. So we don't want to do that, right? So because each one of those points would have their own, and then each one of those would have their own. It would infinitely allocate memory. So yeah, you're absolutely right, Carlos. So we're just gonna do this. In reality, what I would do is I would have a vector of. Yeah, actually, this is actually probably fine, to be honest. Okay, so yeah. I could probably make a constructor that would say, am I an original vector 2 or a history vector 2? There's always different ways of doing it. But for now, I'm just gonna do this. What do you mean you don't? Yeah, you have to download a lot of RAM to do infinite memory. Okay, so do you guys, this is the learning point for today, is that you can write a function that will initialize your variables for you when you have a class. And I use the term class and struct interchangeably because they are. The only difference is you need public for a class. So you can make a, do you see what this looks like? It looks like a function, right? It is a function. It's a function that has no return type. It's not even void. There's no return type. The name of the function is the name of the class. And then you can either pass in parameters or not. If you don't pass in parameters, that's called the default constructor. And it gets called like this. So you say vector2 hi. That is going to call the default constructor. And it's going to set hi.row equal to 0 and hi.column equal to 0. Right? Because I didn't pass any parameters to it. If you pass parameters to it, then it'll call this one. And it has to be 2. Like if you try passing, if I tried doing something wonky like passing 5 parameters, it won't compile. It's got to match. Can you go to hi on the next line? This guy here, DSF. This is kind of how we used to do it. Constructors used to be called using parentheses. We've sort of kind of moved away from that to using universal initialization syntax. We try to use curly braces for initialization. Curly braces kind of mean initialization now, and smooth parentheses mean function call, but both will work. Both are interchangeable. Could you put it on public? Yeah, I can. What do you guys want to call this? I mean, we made a physics simulation. from scratch, right? 20 minutes. What do you want to call it? Kearney game? All right. After its initial, no, constructors only, so we compile it, run it. Ooh, double free. What happened here? Double free. How do we do double free? Double free, double free, double free. Main.cc here. Main2 here. Main2.cc line 85. So that makes them. Do I have a delete still in here somewhere? Those are the only two. I'll have to poke at that a little more. How do you access public files? So I'll copy main to. So it's being freed, and I'm just freeing it again. Oh, yes, 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 yes. This is a great learning point for next time. Yeah, you're going to see the rule of 3 on Zybooks, and yeah, I forgot all about the fact I had a last position in here. So that is. Yeah, so that little mystery we'll talk about on Friday. So copy main2.cc up into public / Kearney. Yeah, let's call it ramen bounce.cc. Okay. So if you want to check out the public directory, you can just cd into /public, and you can look at all the different stuff we've got up there. We've got a lot of sample code and stuff like that. A lot of stuff up there. All right, so this one is found in ramen bounce. So if you want to take a look at that, it's there. Okay, and that is our code for today. So I hope you all learned a little something about constructors and destructors and how they can be used to initialize a class and how to free up memory associated with the class. And when you do that, you don't have to faff around with new and delete really yourself. I mean, do you guys see why this is nice? Right? So you don't really want to ever call new, like just out in the wild. You know, you just really don't, because then you have to keep track of it and like figure out when it goes away, and that's a pain. So if you do it like this, then it allocates the memory when you make it, and it deallocates the memory when it goes away. And there's one other thing we need to talk about, which is a copy constructor, which we'll talk about on Friday. It's called the rule of 3: constructor, destructor, and copy constructor. And that was actually quite good that it showed the bug right there. But we'll talk about that on Friday. Okay. But this is a very nice way of handling heap allocations without having to mess around with pointers and stuff like that, like you did on mountain bridges. So that's it for today. I will see you guys on Friday. Peace out.